In today's video, we're going to be talking about applications of proportions. Similar figures have exactly the same shape, but not necessarily the same size. For instance, a blueprint is smaller than the actual object. Say regarding a scale model. A scale model, for instance, a 1/64 scale car is only 1/64th the size of an actual car. We see this all the time in architectural drawings. You see this if you go to enlarge something on a photocopier or make it smaller. These images are similar to one another, but they are not the same size. Okay? Now, corresponding sides and angles, when we talk about similar figures, are in the same relative position. So they're proportional to each other is what we want to say. So for instance, look at this picture. We have two right triangles, and we're saying that triangle MNP is similar. This little tilde is the symbol for similar. It's similar to triangle STU. They're proportional to each other. In other words, just like if you look at a blueprint of a house and the actual house, they are similar to each other. They are proportional to each other. They're just not the same size. So let's take a look. We want to find side X in triangle STU. Well, side X corresponds to side SU in the drawing. So SU corresponds to side MP. So, for instance, the ratio of MP and SU, and let's see what sides we know. ST, which is right here. Yes, this is the first and the second position in our similarity notation. This corresponds to side MN. So we could say MP, the ratio of MP to MN, is the same as the ratio of SU to ST. Okay, because S and T and M occupy the same positions in our similarity notation, and M and P and S and U occupy the first and the last positions in our similarity notation. Now, all we're going to do is plug in the numbers. So MP is 14, MN is 6, SU is X, we don't know what it is, and ST is 4. Now you have a proportion to solve. So let's go ahead and do that. Remember, we cross multiply. So we say 14 times 4 is 56, and that's equal to 6x. So we have to divide each side by 6, and we end up with x is equal to 9.3 repeating. So that would be 9 1/3 centimeters. Okay, so that's your missing value. Let's look at another problem. Again, when you have similarity notation, the sides and the angles are, let's go back to, are in the same, the corresponding sides and angles are in the same relative position. I'm going back up to our definition at the top of the page. So, for instance, in this problem, we know sides FG and JH in the small pentagon. Well, so let's write those down. FG and JH. Well, I shouldn't say we don't know FG, but we are trying to find side FG. So that's the one, those are the sides we're interested in. So FG in the first pentagon, it occupies the first two positions, so that's going to correspond to the first two positions in the big pentagon, AB. So FG corresponds to AB. JH occupies the third and fourth positions, so it's going to correspond to the side made up from the third and fourth positions in the bigger pentagon. So CD. So we're going to write that down. So we've created a proportion, and now we're just going to plug in the values that we have. AB is 10. CD is 14. FG is X. And JH is 3.5. We're going to go ahead and cross multiply. So we have 10 times 3.5, which gives us 35, and 14 times x, which is 14x. So we're going to have to divide each side by 14, and 35 divided by 14 gives us 2.5, and this is measured in inches, so our missing side up here at the top, side FG, is 2.5 inches. Let's see if we can understand this a little further with this particular problem. A flagpole casts a shadow that is 75 feet long at the same time a 6-foot tall man casts a shadow that is 9 feet long. Write and solve a proportion to find the height of the flagpole. Okay, so let's see. Here's our flagpole, and it's casting a shadow. And then we have a man who's standing here casting a shadow at the same time. And this man is 6 feet tall. He's casting a shadow that's 9 feet long. The flagpole is 75 feet tall. Obviously, this isn't drawn to scale. And we want to know, oh, I'm sorry, the shadow is 75 feet long. I have that in the wrong spot. So the shadow is 75 feet long, and we'd like to find the height of the flagpole. Well, let's see how we can make this proportional. The height of the flagpole, so let's say the height of your object, compared to the shadow, the length of the shadow, would be proportional to the same thing on another object, the shadow of another object that's cast at the exact same time. So in this case, the height of the object would be the man, so that's 6 feet, and his shadow is 9 feet long. So we've created this proportion. We want to solve this by cross multiplying. So we're going to say 6 times 75. So we get 450 is equal to 9x. So we want to divide each side by 9 to solve for x. And we end up with x is equal to 50 feet. So 50 feet is the height of the flagpole. That is it for today. Thank you very much.